So first is elastic material or the elasticity. When force is applied on the object, it deforms, deshapes. But on removing the load, it goes back to its original shape. So this behavior, this property is called elasticity. And the material is called elastic. Number two, plastic material or the plasticity. When load is applied or force is exerted on the object, on the solid, it deforms but does not return to original shape or size when load is removed. It is permanently deformed. So it is called plastic material or the behavior is called plasticity. So the material is called plastic and its behavior is called plasticity. Now deformation is actually in solids change in length, which can be written as delta L, which can be written as E, which can be written as X. So deformation length or extension E or X, again tension or the compression. Now this deformation mean this extension or compression, it depends on original length of the material. Longer the material, more the extension with the same load. For example, we have two wires. One is 1 meter and other is 2 meter. Same diameter, same material, suppose they are from the copper, 1 meter long, 2 meter long, and the same load is hung with them, 5 Newton here, 5 Newton here. If this extends by 1 mm, then this will extend by 2 mm because extension directly proportional to original length. Now, we can write E directly proportional to L, or E extension is equal to length, and this constant, which is the ratio between extension, the original length in physics, is called strain. It's a physical quantity, but no unit. So it is called dimensionless physical quantity. So the ratio between extension and original length is called strain. It has no unit because when extension measure in meter, length measure in meter cancelled, so no unit. Now, this is the first one. Number two, extension is directly proportional to the load applied. So according to Hooke's law, extension is directly proportional to applied load within the limit of proportionality. So this is the definition of the Hooke's law. Extension is directly proportional to applied load within the limit of proportionality. Limit of proportionality mean the end of the directly proportional relation. So we can write F directly proportional to E or X or delta L, and F is equal to constant K into E. This constant K is equal to F divided by E. In A level, it is called material constant, or sometimes it is known as stiffness, but this is the most common material constant. Now, what is the material constant? Look, force in Newton, extension in meter is unit Newton per meter. Now, the definition of this material constant is material constant is the force required by any material to extend through unit length. Mean how much force is required for 1 meter extension. So the force required by the material for 1 meter extension is called material constant. Look, if first material has K1 15 Newton per meter, and the second material has material constant 25 Newton per meter. So it means the first one requires 15 Newton for 1 meter extension, and the other required 25 Newton force for the same extension 1 meter. So definitely this material is hard and this material is soft. So by comparing the material constant, we can decide which material is hard, which is soft. That's why sometimes it's also known as stiffness. जी बेटा, any question? मैंने आपको अनम्यूट किया हुआ है. Any question बेटा? कहीं से कोई आपको चाहिए बेटा क्वेश्चन पीछे जनाब कोई माइंड में आ रहा है तो जरा मुझे बता दें. मैंने यहां से स्टार्ट किया, लेट अगर ज्वाइन किया तो देख लें. इलास्टिक वो होते हैं फोर्स लगाएं तो डिफॉर्म हो जाएं, फोर्स हटा दें तो वापस आ जाएं. प्लास्टिक वो होते हैं फोर्स लगाएं तो डिफॉर्म हो जाएं, और फोर्स हटा लें तो परमानेंटली डिफॉर्म हो जाएं, वापस ना आए. और डिफॉर्मेशन को डेल्टा एल, ई और एक्स से रिप्रेजेंट करते हैं. नंबर वन, एक्सटेंशन डायरेक्टली प्रोपोर्शनल टू ओरिजिनल लेंथ होती है, और फिर रेशियो बिटवीन एक्सटेंशन एंड द ओरिजिनल लेंथ को स्ट्रेन कहते हैं. उसके कोई यूनिट्स नहीं होते, लेकिन है फिजिकल क्वांटिटी, इसलिए डायमेंशनलेस फिजिकल क्वांटिटी. फिर एक्सटेंशन डायरेक्टली प्रोपोर्शनल टू लोड होता है. हुक्स लॉ कहता है एक्सटेंशन डायरेक्टली प्रोपोर्शनल टू अप्लाइड लोड विद इन द लिमिट ऑफ रिपैलिटी. और ये जनाब हुक्स लॉ का फॉर्मूला हो गया, F इज इक्वल टू के ई हो गया। एनी क्वेश्चन? है कोई? नहीं है?
नो सर।
चलें फिर आगे जी, थैंक यू। आगे चलते हैं बेटा। Okay, now F is equal to KE, KX, or K delta L is the formula for the Hooke's law. We have to draw the graph for different materials. Hooke's law, for example, we take a wire, metal, copper, aluminium, any one, force pose plotted at the x-axis and extension plotted at the y-axis according to Hooke's law, straight line passing through the region. So this Hooke's law has the limit, which is called the limit of probability. Suppose the end of the straight line is this, and this is the limit of probability. Now, if extra load is plotted, mean beyond the limit of probability, then there will be bend in the graph like this. The extension will not remain directly proportional to the force. It becomes just proportional. Now, the next point, this one, will be the elastic limit, mean where the elasticity ends. Hooke's law ends at the limit of reality. This is the end of the Hooke's law, and this is the end of the elasticity behavior. And after this elasticity, it becomes plastic, mean permanently deformed. And this last point, this one, is the breaking point. Now, if the load exceeds the elastic limit, this elastic limit, suppose it's loaded up to here, this point, then when the load is removed, this will be the graph for this metal wire. So this is the unloading graph. It's a straight line, but will not pass through the region. Reason, because it is permanently deformed. So this gap on the x-axis is showing the permanent deformation, the extra length achieved. These two graphs will be parallel to each other because the gradient of the graph according to Hooke's law, F is equal to KE, K is equal to F divided by E. So F divided by E is the gradient, so K. So while loading and while unloading, the material remains same. So it's a material constant. That's why the gradient is same. So this is the graph for the metal. It's elastic, it obeys Hooke's law, but when the limit exceeds, it becomes permanently deformed, and this gap is showing the permanent deformation. And the graph, straight line, suppose this one, when we will calculate the gradient will give you the material constant, and area under this straight line, which is a triangle, will give you the strain energy, mean elastic potential energy. So area under the graph is equal to strain energy, which is elastic potential energy. Now the area of the triangle is equal to 1 by 2 into base. The base is extension and the height is the force. So the strain energy formula is equal to 1 by 2 Fe. This is elastic potential energy formula. But wire is obeying the Hooke's law, and according to the Hooke's law, F is equal to Ke. So F can be written as Ke into E So we can write another formula for the kinetic energy, 1 by 2 ke square. So this is formula number 1. This is formula number 2 for the strain energy. Now, if the graph is plotted between extension and the force like this, force at the x-axis, extension at the y-axis for the metal again is a straight line passing through the region, but now the bend will be upward towards the extension. The gradient of this line will not be k, it will be the reciprocal of the k, mean 1 over k, and this is the end of the straight line, mean end of the Hooke's law, mean the limit of reality end, and the next point will be the elastic limit, and the last point will be the breaking point. Now, when the load is exceeded, then the limit, suppose up to here, then this will be the unloading graph, and this extra length, this one, will be the permanent deformation. Now the area under the graph will be the same, half base into height, but if the question is shade the area, which is representing the strain energy, then we have to shade always the area adjacent to the extension. So we will shade this area. Formula will remain same. And here we will shade this area because this is extension. Reason, energy is equal to work, and the work is FD. So work is only done when the distance is covered. So we have to shade the area adjacent to the distance covered by the wire, mean extension. So area is always shaded adjacent to the extension. So here it's down the line and here it's up the line. So formula will remain same. Okay, so this is the graph for metals. And sometimes metals are called ductile materials because they are elastic. During elasticity, they obey Hooke's law, and after elastic limit, they becomes permanently deformed, mean plastic behavior. Now, suppose we have another materials, glass. Force at the y-axis, extension at the x-axis, straight line passing to the region, and this is the end of the Hooke's law. This is the end of the elastic limit, and this is also the breaking point because the graph is just a straight line. Okay, so the elastic limit is the breaking point. This glass has no behavior like plasticity. It has no plastic behavior. When load exceeds then its limit, then it breaks. No permanent deformation. So this is the graph for the glass. Similarly for the ceramic, and these materials are called brittle materials. So they are elastic. Within the elasticity, they obey Hooke's law, but when the load exceeds, they break suddenly. There is no permanent deformation in the glass at the same temperature, at the room temperature. But if we want to deform it permanently, definitely then you have to increase its temperature. You have to heat it up. But at the room temperature, no such plasticity. Now come to the rubber, the third material. It is elastic but does not obey Hooke's law. This is the force, this is the extension. It is elastic. Being elastic, it does not obey Hooke's law. So it's not a straight line, it's a curve like this. This is the loading line for the rubber. So this is loading. Now the area under the line, this is representing the energy which is supplied to the rubber for stretching, mean load applied for extension. When it is unloaded, so this will be the shape of the graph. So this is unloading line. Again, not straight line. Now two areas. One is inside the loop and other down the loop. Now the area x plus y, mean the total area, is representing the work done on the rubber to extend it. Mean energy supplied to the rubber. And the area just y is the work done by the rubber. Mean energy released by the rubber when it is unloaded, and the area just x within the loop is actually the energy which is not released by the rubber, it is absorbed by the rubber. In which form? Heat form. It is absorbed in the heat form. Hence, during stretching, the temperature of the rubber increases. It does not obey Hooke's law, but it's elastic. So first graph for the metals, second graph for the glass, and the third for the rubber. Rubber does not obey Hooke's law. Now, any question? जी बेटा, any question? है कोई? मैंने आपको अनम्यूट कर दिया है.
No, sir.
श्योर? फिर भी देख लें बेटा. No question? Okay, next, number 3. Extension also proportional to change in temperature. When temperature increases, extension increases. Number 4, extension is inversely proportional to cross-sectional area of the material, mean the thicker wire will extend less. And number 5, extension is inversely proportional to the material constant, mean harder the material, smaller the extension. जी बेटा, any question? कोई जनाब क्वेश्चन माइंड में आता है तो पूछें.
सर रबर के ग्राफ में अगर एक्सेस चेंज करेंगे तो लोडिंग
हम्म.
लोडिंग और एनर्जी कौन से लेंगे?
एनर्जी का फॉर्मूला वही रहेगा, हाफ बेस इनटू हाइट, बस.
ठीक है सर.
जी, क्योंकि फोर्स मल्टीप्लाई बाय, देखें ना, 3 मल्टीप्लाई बाय 2 करें या 2 मल्टीप्लाई बाय 3 करें, द आंसर विल बी सेम. लेकिन जो ग्रेडियंट होगा वो तो चेंज हो जाएगा ना. ये पीछे से सारा देख लें, एक दफा पढ़ लें. क्वेश्चन है तो पूछ लें. ये पढ़ लिया आपने? इसको देखें. जी, कोई इश्यू है इसमें? ये हुक्स लॉ की डेफिनेशन, उसका फॉर्मूला ये देख लें। उसके बाद ये मेटल का ग्राफ, एंड ऑफ द स्ट्रेट लाइन जो है ना वो हुक्स लॉ है, लेकिन इलास्टिक लिमिट थोड़ा सा ज्यादा भी लोड लगा देंगे तो वापस आ जाएगी, इसलिए इलास्टिक लिमिट थोड़ी सी ऊपर होती है, लेकिन डायरेक्टली प्रोपोर्शनल पहले ही खत्म हो जाता है। और अब एक्सेस अगर चेंज कर देते हैं तो मटेरियल कांस्टेंट जो है, एक का ग्रेडियंट हो जाएगा, दूसरे का 1/k हो जाएगा ग्रेडियंट, लेकिन एरिया वही रहेगा, लेकिन शेड ऊपर वाला करना पड़ेगा फिर, क्योंकि वर्क के लिए डिस्टेंस कवर करना बहुत जरूरी है, इसलिए डिस्टेंस वाले जो एक्सेस है ना उसको शेड करना है आपने। एनी क्वेश्चन? जी बेटा, है कोई इसमें क्वेश्चन? उसके बाद ये ग्लास के लिए, तो ग्लास जो होता है, ग्लास जो है वो परमानेंटली डिफॉर्म नहीं होता, वो अगर लोड ज्यादा लगाएंगे तो ब्रेक कर जाता है। और हाँ, अगर परमानेंट डिफॉर्म करना हो तो फिर टेम्परेचर का ज्यादा करना पड़ेगा आपको। रूम टेम्परेचर पे वो परमानेंट नहीं डिफॉर्म होगा, थोड़ा सा एक्सटेंड करके ब्रेक कर जाएगा, इसलिए स्ट्रेट लाइन के बाद खत्म। और यही बिहेवियर सिरामिक्स का भी होता है, लेकिन ये जो रबर है ये बहुत अच्छा इलास्टिक है, लेकिन हुक्स लॉ को बे नहीं करता, इसलिए इसकी कर्व बनती है, लोड करते हुए ज्यादा एनर्जी देनी पड़ती है, जैसे है ना कैटापल्ट होती है, गोलेल होती है, आप उसको एनर्जी ज्यादा देंगे, उसको पीछे खींचेंगे, लेकिन आप उसमें से पैलेट रख के आप उसको छोड़ेंगे ना, लेड शॉट कोई, तो उसको काइनेटिक एनर्जी कम मिलेगी, रबड़ अपने पास रख लेगा एनर्जी। तो कितनी एनर्जी अपने पास रख लेगा, ये एक्स जो लूप है इतनी एनर्जी वापस देगा ही नहीं, तो इसलिए दोनों एरिया जो है वो सेम नहीं है, एक्स प्लस वाई ज्यादा होता है और नीचे वाई जो रिलीज होती है वो कम होती है, और ये एनर्जी हीट की फॉर्म में अपने पास रखता है, इसलिए रबड़ को खींचते हैं तो वो गर्म हो जाता है। उसके बाद एक्सटेंशन चेंज ऑफ टेम्परेचर के साथ भी डायरेक्टली है, लेकिन अगर एरिया थिक होगा तो इन्वर्सली हो गई, और मटेरियल कांस्टेंट आपके पास अगर ज्यादा होगा, हार्ड होगी चीज, तो फिर भी एक्सटेंशन कम होगी। जी आज के लिए काफी इतना, या और पढ़ें? मीटिंग खत्म होने वाली है, दोबारा ज्वाइन करना है या? जी काफी है। हाँ चलें फिर इंशाल्लाह कल, ठीक है। अभी मीटिंग खत्म हो जाएगी खुद ब खुद, लेस देन 1 मिनट आ रहा है।
शुक्रिया सर, अल्लाह हाफ़िज़।
अल्लाह हाफिज। इसको रिवाइज करना है, रिकॉर्डिंग भेज दूं?
भेज दें सर।
अच्छा चलें, रिकॉर्डिंग जो है होगी ना तो फिर मैं इंशाल्लाह शेयर कर लूंगा, ताकि आप रिवाइज कर सकें ना।